So this lesson is on inductive and deductive reasoning. This is our next outcome, which is NL3. So we're going to be talking about inductive reasoning and deductive reasoning. So here's a little table highlighting for you the difference between what inductive and deductive reasoning is. So the best way to kind of observe this is through an example. So what happens is you use specific observations, like you're looking at observations, and then you try to make a conclusion based on what you're looking at. With deductive reasoning, you kind of make a conclusion that is coming from some theory that you're observing. Okay? So when I look at this first example, every quiz has been easy, and then I'm going to make a conclusion that says, therefore, the test will be easy. But we know that this may or may not be true, but just based on the observation, the quizzes have been easy so far. We'd assume that the test will be easy, but that's just based on the observations. Okay, this one is a little different because what happens is all students in the class play guitar. Sam is a student of the class, therefore he's going to play guitar. That's sort of going to be like a true statement because you're coming from it based on the theory that we have here. All the students in the class are playing guitar, so that he's a kid in the class, and therefore he has to be able to play guitar. Okay. Another example here is the teacher used PowerPoint in the last few classes, therefore the teacher will use PowerPoint tomorrow. That's not going to be true. Obviously, yesterday I was teaching you on the smartboard, and today I'm not. So those are examples of inductive reasoning. And deductive reasoning. So here at a conference, all the people present are 30 or older. Maria is in the room, so therefore we would have to assume that she's at least 30. So this is coming from some statements that are already true, and then we're making another statement based on these statements that are already true. Now, what we're going to do first is learn how to make a conjecture. So in order to make a conjecture, we just want to make a statement looking at what's given to us. So we're going to look at patterns based on scenario given, and then we're going to write an educated guess on what we think is going to happen. Okay, so when we look at this first example, I see a sequence of numbers 1, 1, 2, 3, 5, and I want to try to figure out what's happening in this sequence. So as I look at it, I may notice that when I look at those two numbers, 1 minus 1 is 0. Oops, 1 minus 1 is equal to 0. I may notice that 2 take away 1 is 1. I may notice that 3 take away 2 is equal to 1. I may notice that 5 take away 3 is 2. When I look at these numbers, I don't really see much of anything. There's sometimes what you may see is that these numbers may all be 1, and then we can maybe make a conclusion based on that. So let's take this out, and then we're going to try something different. Now, if you look very carefully at this sequence of numbers, we might notice that these two numbers, when I add them together, 1 plus 1 is equal to 2. Hey, wait, that's the next number in the sequence, right here. Then I may look at the next two sets of numbers, 1 and 2, and I might be like, hey, wait, 1 plus 2 equals 3, and that gives me the next number. And if I continue going through with this observation, 2 plus 3 is 5, and 5 plus 3, I would assume, okay, maybe there's something going on here because I've been able to get all the terms by observing just this first part of the sequence. So I'm going to make an educated guess. I think the next number in the sequence will be 8. Okay, that's my educated guess. So when I write a conjecture, I just want to write it a little bit fancier. The next number in the sequence 1, 1, 2, 3, 5, comma, dot, 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 will be 8. So that would be my conjecture. Let's look at another example. What is the next number in the sequence? So observations. What do we notice? I notice that if I look at 1 to 8, maybe I multiply by 8 to get to 8. Maybe from 8 to 27, maybe multiply by 8. Wait, no. 8 times 8 is 64. So I tried to think of a pattern there. That didn't work. Let's try something different. Maybe if I try to do 8 take away 1, I get a 7. And then I do 27 take away 8, and I get 19. I don't think there's anything happening there. But then, wait a minute. We've learned things where I look at 1 cubed, which is 1 times 1 times 1, which are my dots are multiply. And this gives me 1. Hey, that's the first term. Then maybe I look at the next one. Well, what if I do 2 cubed? 2 times 2 times 2 equals 8. This is the second term. I think I'm getting somewhere now. So when we're doing our observations, we want to try to make it so that we're getting somewhere through observing what's happening in the scenario that's given to us. 3 times 3 times 3 is 27. Hey, this will be my third term. So these are my observations. My educated guess will be, okay, well, I would assume that the next one might be 4 cubed, which is 4 times 4 times 4, which is 64. So I think the next term will be 64. So when I look at my educated guess, sometimes we can do this kind of with the conjecture as well, based on the patterns we've already noticed. The conjecture is just a fancy way of writing it out. The next term in the sequence, and let's write the sequence that we were given, 1, 8, 27, comma, dot, 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 will be 64. That would be a conjecture, just an educated guess on what we think is going to happen. This conjecture may or may not be true. So we're not saying that this will be true all the time. We have no idea. This conjecture may or may not be true. We're just kind of looking at the patterns and then deciding what we're going to think is going to happen. Okay, let's look at this one. Develop a conjecture for the what's my number riddle. Now you'll notice I call this riddle a name. This name is called what's my number. We're going to be seeing these examples more. So when I look at this, I need to think of what are my observations. So I look at this riddle and it tells me to choose a number. So let me just randomly choose a number. Let's say the number I choose is 5. Then it asks me to double this number, so that would be 10, because 5 plus 5 is 10, or 5 times 2 is 10. Add 5 to it, so let's write double. Add 5, so 10 plus 5 is 15. Add your original number. Add original number, which is 5. So 15 plus 5 is 20. Add 7. So 27, or 20 plus 7 is 27. Divide that by 3. So 27 divided by 3 is 9. And then subtract original number. Okay, which my number was 5. So 9 minus 5 is equal to 4. So I've done the observation once, but this doesn't mean anything. I have to try it again so I can see, is there something happening? So let's choose a different number. 3. Double it, 6. Add 5, I get 11. Add your original number. 11 plus 3 is 14. Add 7, so 14 plus 7 is 21. Divide by 3 is 7. And then subtract original number. 7 minus 3 is 4. Hey, now wait a minute. I see that the first time I chose a number I got 4. The second time I chose a number I got 4. This is enough observations for me to come up with an educated guess. I think the answer to the what's my number riddle will be 4. The solution to the riddle will be 4. As you're working, you may not have to write the educated guess down all the time. You may be able to go straight from the observations to the conjecture if you feel comfortable. So what we're going to do is we're going to expect you guys to try out the following examples. You're going to look up some observations for the product of two integers. You're going to come up with a conjecture. You're going to look at the sum of two even numbers, get a conjecture, and so forth. In some of the following videos, we will have the solutions to these examples available to you as well. But in the meantime, just things to talk about. Product means we're multiplying. Odd numbers are 1, 3, 5, 7, 9, etc. Integers are allowed to be positive or negative numbers. So keep that in mind as you're working through that question. Sum of two even integers. Sum means we're adding. Even, we're talking about 2, 4, 6, 8, comma, dot, dot, dot. 0 is also considered even. Integers mean positive or negative numbers. Difference means we're subtracting, usually the bigger minus the smaller. Okay, consecutive means one after the other. So if I'm talking about consecutive integers, I could be talking about 1, and then the next number would be 2. But this, we want to do one after the other of perfect squares. And perfect squares are the numbers we talked about before. 1 squared, which is 1. 2 squared, which is 4. 3 squared, which is 9, etc., etc. So my perfect squares are 1, 4, 9, and you can keep going with that. Sum of the digits in multiples of 3. Multiples of 3 mean I'm counting by 3s. 3, 6, 9, 12, and so forth. Digits mean if I looked at the number 12, the digits would be 1 and 2. Fewest number of triangles in a polygon. They give you a polygon, which is a shape shown below. Sum of one odd integer and one even integer. Square of an odd integer. So square means you're taking your number and putting the symbol 2 as an exponent. Number squared. Okay, pattern, there's a pattern there for you. Circle, circumference, these are words that you may need to think about. On the edge of the circle,